Welcome to Calculus.
Our stress tolerance level has risen so high that nothing phases us.
On this episode, Stevenson will demonstrate
find the absolute extrema of f of x equals sine of x plus pi over 4 on the closed interval from 0 to 7 pi over 4. First step is to figure out, does extreme value theorem apply? Well, this is my sine wave, and all it's been done is shifted to the left pi over 4. My sine wave looks like this, and it is continuous everywhere. So remember, the requirement for extreme value theorem is the function must be continuous on a closed interval. Well, sine wave is continuous everywhere no matter how I move it, and this is a closed interval, so yes, extreme value theorem applies. What this means now is I am guaranteed both an absolute max and an absolute minimum. Next step is to find my derivative. Now that I have my derivative, I need to find my critical points. So I'm going to set my derivative equal to 0 and also find when does my derivative not exist. Now, in order to figure out where my derivative equals 0 or does not exist, I need to know, well, what does this look like? And I'm also going to use my unit circle here. I know the regular cosine wave starts up here at 1 and then comes back. I can use this to guide myself in figuring out these values. I can also think of the unit circle. When is cosine 0? In other words, when does this... So ignore the pi over 4 is what I'm asking you to do right now. In general, when is cosine 0? So think of your unit circle. Cosine is 0 at pi over 2 and 3 pi over 2. Now that's if it was regular cosine. Because it's being moved to the left it's moved to the left pi over 4, then I'm going to modify these slightly. So let me show you how you do that. What you want to do is you want to take what's inside your cosine function and set it equal to the value we want. See, what we want to be inside evaluated by cosine is pi over 2. Why? Because when that happens, I get out 0. But I don't have a single x here, I have an x plus pi over 4. So I take the expression inside my cosine function and I set it equal to the angle that I need that will make cosine 0. So this is just fractions. Pi over 2 minus pi over 4 is pi over 4. Now I have one more angle I need to find out. So again, I take my expression inside my cosine function, I set it equal to the angle that I need so that when I evaluate cosine, I get 0. Now, is there any points where the derivative will not exist? Well, the derivative is a cosine function, right? And it's on the interval from 0 to 7 pi over 4. Cosine's continuous everywhere, so no. There is no spot where the derivative will not exist. Now let's check before we make our table, are there any values we need to exclude? Well, pi over 4 is in this interval and 5 pi over 4 is also in this interval. So what this means in our table of values is we're going to have 1, 2, 3, 4 x values to test. Now remember, we're testing in the f of x, which is up here. We are not testing in the derivative. I'm going to do some scratch work off to the side here as needed. Now, what we can see here is the absolute minimum will be -1 when x equals 5 pi over 4, and the absolute maximum is going to be 1 when x equals pi over 4. You may be wondering, how did I know that this was going to be less than 1? Here's how. I know the square root of 2 is like 1.141, so if I do half of that, it's like a 0.7 something like that. Okay, I know the square root of 3 is about a 1.7. So again, if you just know some of these decimal values, then you'll be able to quickly estimate what this value is. So now let's answer the question.